For the last 4.5 billion years, our Earth has been under attack by meteorites. Now, of course, most of these meteorites arrive leaving nothing more than a beautiful trail of shimmering lights in the night sky. But every now and then one does make it through, and when it does, it can cause potential devastation on the order of a nuclear holocaust. The last major event, the Tunguska meteor that exploded over Siberia in 1908, caused devastation on the order of over 1,000 Hiroshima-sized nuclear bombs. But on September 28, 1969, at exactly 10:53 a.m., just outside the small town of Murchison, Australia, a very special, and indeed a very rare, carbonaceous meteor arrived bearing a gift inside its well-protected core. A gift that could change the practice of medicine for millions of people around the world that suffer from chronic and debilitating pain. A gift that started its journey in a distant galaxy many, many, many millions of years ago. A gift that Dr. Ernie Puhl, a professor of pharmacology at the University of British Columbia, explains. So Dr. Puhl, tell me a little bit about how you came up with the idea to seek out isovaline from a meteorite, no less, as a possible pain inhibitor.
About 5 years ago, my colleagues and I at the Hugel Center for Anesthesia and Analgesia here at the University of British Columbia found that certain amino acids were inhibitory neurotransmitters in the brain. The discovery got us thinking about how we could relieve pain. So we went to the chemists and we asked if they had chemical compounds that looked like these simple amino acids. And they came up with several, including isovaline. Now, isovaline was new to us. The chemists said that isovaline was first found on Earth in a meteorite. So meteorite source was hard to believe. Surprisingly, there were no reports of the effects of isovaline in the body. The chemists synthesized isovaline for us, and we experimented with it. In our tests, isovaline suppressed the activity, the excitability of neurons in the thalamus, and had pain-relieving properties when applied to pain models. Isovaline may not be the ultimate drug. The actions of this chemical on neurons in the brain are unusual, and they suggest to us a new class of analgesic substances.
So really it's about a whole new class of drugs. We know about morphine, of course, and all the horrible side effects, and NSAIDs like aspirins and ibuprofen. This is yet a whole new category of painkillers.
Yes.
How could this discovery change the face of medicine as is practiced today?
Well, chronic pain affects a very large number of people in the world and is the #1 cause of disability. If one could develop a drug specific for this pain and without the limiting effects of morphine, then we'd all be happier with physicians.
Now you realize this is really, and pardon the pun, out there. So how has the scientific community reacted to this?
Well, it's too early to say because our results in vitro have just been published and the results in pain models are in press.
Tell me about a world without pain.
Well, pain is an important sensation, drawing attention to a problem. There are many forms of persistent or chronic pain. For example, backache. Severe pain that persists for a very long period of time can lead to suffering and serves no further purpose. On the other hand, people without their chronic pain would be happier and able to engage in useful activities.
You know, we're living in an age where there's a lot of attention focused on the cost of drugs. What about the cost of this?
Isovaline would be inexpensive given reduced manufacturing costs. After preclinical and clinical studies, it may very well turn out that isovaline is not the ultimate drug. However, a derivative of isovaline may be more costly. It's hard to say.
Dr. Puhl, I remember a few years ago a drug that came out supposedly for treating heart problems. Turned out that Rogaine wasn't that great for the heart, but it sure grew a nice head of hair. In the event that isovaline turns out to not be appropriate for pain inhibition, is there any thought that it might be useful for something else?
The actions of isovaline on neurons suggest an anti-epileptic property.
You know, whenever a new drug comes out, of course, everybody knows there's a potential for side effects. What kind of side effects are we looking at for isovaline?
As far as one can tell, there are no side effects in our tests in rodents.
When am I going to be able to open up my medicine cabinet and see a jar of Dr. Puel's pain pills?
If it turns out that isovaline satisfies the requirements of efficacy and safety in humans, then it'll have a lot of names on it.
Today you've told me about compounds arriving on Earth via meteorite that are going to be used in medical research. What does NASA have to say about all this?
NASA scientists found that meteorites with isovaline have more water. They suggest that this has something to do why early life on Earth chose 20 left-handed amino acids over right-handed ones. Isovaline wasn't one of them, but isovaline may help them in their quest for extraterrestrial life.
People are going to be watching this segment. They're going to be thinking what you've had several years to think about. Why Earth? Why this compound? Explain.
Extraterrestrial life may incorporate isovaline in chemical makeup. Since it arrived here from space, it's surely from a distant land. I am as intrigued as anyone else would be about potential implications of the reason for its existence in a meteorite.
So great news if you're a rat suffering with headaches at the University of British Columbia.